Qwen 3.827b is here, and after my initial testing, I think this model finally deserves the praise that the internet, in my opinion, prematurely gave to 3.6. You could feel that 3.6 had greatness in there, but using Unsloth or Bartowski, etc. on llama.cpp, it was a bit lacking. Even when using the recommended temperature settings of 1 or 0.6, based on the type of workload, it couldn't solve some of my standardized tests. However, on a llama, things changed. 3.6 became much more consistent and was able to solve all 3 of my tests perfectly. Which begs the question, what the heck is a llama doing? Perhaps they have some extra templating going on. But the downside was Ollama was slow and still thought a bit too much, which made it an impractical choice for me. So that brings us to the current release, 3.8, and this is a great one. It's really a refinement of 3.6. All the things I had just said has been addressed in 3.8. You could call this release 3.6 Unleashed. You can now choose any platform that allows you to specify a reasoning level. So you can use Llama CPP or Ollama, and it doesn't matter. Reasoning by default is X high, but I'd recommend using medium. It's the sweet spot. For example, in my coding test, X high takes 14,000 tokens, whereas medium takes anywhere from 5 to 8,000. Also, 3.8 now is twice as fast. Just activate MTP on Llama, CPP, and Ollama seems to automatically do it. Back with 3.627b, the only inference engine that could get a perfect 30 out of 30 on my test was on Ollama, but at a highish 19,000 tokens over the 3 tests. Yes, way better than the 90,000 tokens generated by Nemotron 3.5 Lightning, but not as good as Gemma 431b, which does it in almost half the tokens, around 10,300. Now with 3.8, it did it in only 10,200 on Llama CPP, which is even better than Gemma 431b, the reigning champ by 120 tokens. But what's up with the 29.5 instead of 30, you ask? Well, this I could not ignore. Across multiple tests on both Llama CPP and Ollama, it showed up, specifically on the financial test. Randomly, it would generate transcription errors, outputting incorrect arithmetic. It's rare, but the fact that it happened on both inference platforms means it's probably part of the model. Perhaps it will disappear at higher quantizations. So unfortunately, 3.8 gets a 29.5 out of 30. Only frontier models like Opus 5 and Grok 4.6 were more efficient in solving my tests. And finally, a UI test, the Electrical Circuit Explainer, a vague prompt to create an interactive HTML page to explain electrical circuits and show the creativity and personality of the model. 3.8 generates one of the nicest looking pages generated by a local model. But just like 3.6, there's a few flaws. The electrons that show the flow through the circuit doesn't work, a core concept that should be working. Also, it's nice that it tries to cover parallel circuits, but then it shouldn't produce nonsense and confuse the learner. So I put this at 8 out of 10. Gemma, on the other hand, does the bare minimum but executes it almost flawlessly, for a 9.5 out of 10. And this time, both Llama CPP and Ollama have fairly equal reasoning capabilities. Just remember to use medium setting. But now you are free to use whatever platform you like. Ollama seems to add additional templating because the model is slightly more verbose than Llama CPP, but now they're basically in the same range. So with the more efficient reasoning and faster speed in one package, along with Qwen's gated delta net layers resulting in large contexts with high fidelity, I think 3.8 could be particularly well suited to agentic workloads when a model is working autonomously for a long time. Speed matters, reasoning efficiency matters, because we don't want to be generating 500 million tokens needlessly. It hasn't completely solved overthinking. I asked it to write 100 words on a topic and it went off and generated 5,000 tokens before answering. But it's much more controllable now, and I feel largely solved. The gap has closed with Gemma 431b, and it'll be interesting to pit them against each other for larger agentic workloads. And that's where we're going next. See you there!